Good afternoon, everyone, and welcome to this special session. We are dealing with Newton laws of motion, and we are dealing with motion of connected bodies. I think in the previous class we had seen the concept of how we can take two blocks or three blocks as one system, and how we can get the answers for their accelerations very quickly. Yes or no? Do you remember it? Now, what we are going to do today's class is we are going to extend that and see how and where all we can apply this. So let me make you another question, and if you understand the concept, you should be able to solve it very quickly. So let me give you a question. I think I have it already here. So I will just take a picture and instead of me writing, it's better that I can show you a picture. So this is the case here. I have two blocks. Now they are not in touch with each other. They are not touching each other, but instead of they touching each other, I have a string connecting them. Now, how many strings do you see in this diagram? How many strings are there? Now, if I say that if this is string number one, this is also string. So I'm applying a force F on the string. I'm pulling it with the force F. Maybe there is string on the other side as well, but there is definitely one string which is connecting the two blocks m1 and m2, right? And I'm applying a force. So what is known to you is the force applied, and you know the two blocks are having masses m1 and m2. What they are going to ask you in this question is find out the acceleration of the two blocks. So you have to find out the acceleration of the two blocks, and you have to find out the tension between the two, tension in the string connecting the two blocks. I'll give you 2 minutes and I'll hope that you are able to solve it. I'll show you the entire way, and then I'll show you the shortcut way, and then I'll hope that you can remember it. So I'll give you 2 minutes. Write the question, settle down, tell me the answer, and understand the concept. Sorry, your voice is not coming clear. Can you try again?
F by m1 plus m2, sir.
Yes, that would be the value of acceleration. What about the tension in the string between the two blocks? How much is that tension?
Sir, M1 F by M1 plus M2.
Okay, that is absolutely correct. Now, what is the actual way of doing it? The actual way of doing it would be step number one, draw the sketch. Sketch is there. Step number two, draw the free body diagrams. I'll draw the free body diagrams. M1G, this is N1. Then there is tension T in the string here. So this blue thing becomes the free body diagram of this blue block. Yes or no? Then let me draw the free body diagram of this block. The weight is M2G. The normal reaction is N2. There is a force F already here. Then there is a force on this tension T because of the string pulling it back. If I call this block as the green block, this is the free body diagram of the green block. Yes or no? We understand this? Now remember, these blocks are attached to the same string. So they must move together, otherwise the same string will become slack or whatever. So both of these blocks are moving forward with an acceleration A. Everyone understands this? Now I can write the equation for the two blocks. I can write the blue equation N1 is equal to M1G. That will not serve any purpose right here. N1 is equal to M1G. We know this. Now what you see here, this T is in forward direction, but there is no force in the reverse direction. So what will be the equation for this block? The equation for this block would be T is in the forward direction. There is no force in the backward direction. So what is the equation of block number one? What is the equation for block number one? Anyone forgotten it? No one knows the equation for block number one? Am I audible and visible to all of you? No one knows the equation for block number one? Well, I'll give you 5 minutes to read what we had done in the previous class.
T is equal to M1 Newton.
Okay. So someone has told me T forward acceleration is also in the forward direction. So T is equal to M1A. That becomes the equation for the first block. Let me move on to the second block. N2 is upper, M2G is downwards. It is not going to move in this direction. So I will get N2 as M2G. Now let us look at the equation along x-axis. F is forward, T is backward, and acceleration is forward. So what will be the pink equation of this block?
F minus T is equal to M2A.
Yeah, so I will write this equation here, let us say. So I can write this equation in this fashion. F minus T is equal to M2A. Here it was M1A. I can add these equations and I will end up, if I call this equation as equation number 1, if I call this equation as equation number 2, I can add up this equation. I can get the value of A. The value of A that I will get will be F upon M1 plus M2. As soon as I get the value of A, I can put the value of A in this equation and I will get the value of T. Yes or no? This is the actual way of doing it. by doing it separately. But again, I can do this question in a more simpler way. How can I do it in a more simpler way? I can take both of these blocks 1 and 2 as one system. I can take both of these blocks 1 and 2 as one system. Then what do you see in this system? There is only one force, which is F, acting in this direction. Yes or no? External force in the horizontal direction is F. There is no force in the backward direction. Both the blocks are going to move with the same acceleration. So I can straight away write acceleration will be F upon m1 plus m2. Do we understand this? Once you get the value of A, what you can do? You can again take this pink block as one system. The only external force in the horizontal direction is T. T will be equal to ma. You put the value of A from here into this equation and you will get the value of tension between the two blocks. Do we understand this? So you do it by process number 1 or you do it by process number 2. The method remains exactly same. Do we understand this? So once you understand this, probably you would be able to give me the answer for this one. Again, now instead of 2 blocks, I have 3 blocks. It could have been 4 or 5 or 10. Can you give me the answers of what is the acceleration of this system and what is the value of T1 and T2? And this time I will not do them separately because I have already told you how to do them separately. Now let us try to get the answers quickly. You must understand that all these 3 blocks are going to move with the same acceleration. We can apply this concept whenever the blocks move with the same acceleration. I'll give you 2 minutes to give me the value of F. F is the force. F is given to you, m1 is given to you, m2 is given to you, A is given, m3 is given to you. You have to find out the value of A, which is the acceleration of these blocks. To find out the value of A, you have to find out the value of T1, you have to find out the value of T2. What about T1 and T2? I know that you know how to find out A. I know that. I know that. I want you to tell me the value of T1 and T2. Then only I'll understand whether you have understood it or not. I'll give you 2 minutes to do this.
Sir, T1 is equal to M1A.
What about T2?
A of M1 plus M2.
Not A of, A multiplied by M1 plus M2. Not A of, A multiplied by M1 plus M2. Correct. That is correct. Everyone got this? Yes or no? Yes, then I can move ahead. I understand this entire system. This entire system is going to move forward with an acceleration A. Everyone understands this. Once you understand this, you can take case number 1, all these 3 blocks as one system. The forward force is F. There is no reverse force. So as soon as you make it as one system, you get the first answer. F will be equal to M into m1 plus m2 plus M3 multiplied by A, or I can write A will be equal to F upon M1 plus M2 plus A3. Do we understand this? This is how I get by solving it 3 as 1. Now, if I have to get the value of T2, what is the shortest way? To get the value of T2, you can take A and B as one system. If you take A and B as one system, there is only one force which is trying to pull it in the forward direction, and that force is T2. Do we understand this? There is no force in the backward direction. Once you realize this fact, you can write the green equation here. T2 will be equal to M1 plus M2 multiplied by A. You already know the value of A. You can find out the value of T1 and T2. Lastly, if I have to calculate the value of T1, what do? I take this block as one system. The only force on this block is in the forward direction, and that is equal to T1. Now I can write the blue equation for this block only in the forward direction. The only force is T1. This T1 will be equal to M1 into A, and you end up with all your answers. Do we understand this? Okay. Can we move on to the next category of questions? Well, in next category of question, what is going to happen is let me see if I have one already so that I can just copy it down from there. No. Okay. Okay, now I have a block on an inclined plane. We have seen questions on the block on the inclined plane. We have seen that if this block is free to leave, it will move down. What was the expression of this block? It was kept on an inclined plane. And how much?
5 meter per second square.
G sine theta, G sine 30 degrees, right? Okay. If I now apply a force in the upward direction, and let us say that this force is 25 newtons. Can you now tell me what will be the acceleration of the block? So this is the simplest possible question that I could have made. I'll give you 2 minutes to solve this. Remember, we have to do simple things. If you do them correctly, we should be able to solve any question that comes. Yes. What is
Bearing,
that?
sir. 0.
0 will remain at rest. How did you get 0? Okay. So how did I get 0? First of all, I have to draw the sketch. Sketch is there. I draw the free body diagram. This is 50, 5G. mg. This one is mg sine 30. Sine 30 is half. 50 multiplied by half is 25. Then this is 50 cos 30. Cos 30 is root 3 by 2. So I get it as 25 times root 3. This is the normal reaction. Everyone understands this? How I've done this? I've done it many times. How will I make the equation? Here I will make my axis, my x-axis like this and my y-axis like this. And you can see it cannot move dum 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 dum. That means 25 root 3 will be equal to n. Yes or no? That is the first equation that I get. Now I look at the x-axis and what do I find on the x-axis? That the force which is trying to pull it up is 25. The force which is trying to pull it down is also 25. Can it move? No. If it is at rest, it will remain at rest. So the acceleration of this block becomes 0. Do we understand this?
Sir, we are unable to see.
Oh, sir, you are unable to see. Oh, okay. Now you can see it. Okay, I will.
Sir.
Okay, so again, I'll repeat. I have drawn the free body diagram. 50 newtons is downwards. I have taken the sine theta component, 50 sine 30, which is 25, 50 cos 30, which is 25 root 3. It does not move along the, it does not move perpendicular to the plane. So n becomes 25 root 3. Upward force which is trying to pull it up is 25. Downward force which is trying to pull it down is also 25. That means it does not move. It remains at rest. Acceleration is 0. Do we understand this? Girls, boys? Okay, I'll give you a minute to note it down. Then I will change something in this question and then you can see what happens when I change it. Noted it down? Shall I move ahead?
Yes, sir.
Now I have changed something. I have changed the force from 25 to 20 newtons. And now I ask your answer, suggestion. What is the answer now? 20 newton trying force is trying to take it up. What is the acceleration of the block? You have to tell me also whether it is going to move up or whether it is going to move down. You have 2 minutes to give me the answer.
Five meter second, sir.
5. Too much, too much, too much. Five is too much. Think again, think again, think again. Try again, try again.
Very good.
Yes, beta? Okay, everyone has done this. Can I solve it now? Okay. Step number 1, draw the sketch. Sketch is there. Step number 2, draw the free body diagram. I draw the free body diagram. This is 50. Now I know that this is half of 50 because this is sine 30. This is 25. I know this is 25 root 3. I've done it so many times, not a problem. Then I know this is n. I'm going to make the equation like this. I don't even have to draw that axis because now we know it. Then your ding 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 ding. This will become 25 root 3. So many times it has happened. Now I have to look very closely, and that's why I've got specs. My eyesight was getting weak. Now, what you see is the force which is trying to pull it down is 25. The force which is trying to pull it up is 20. Who wins? Huh? Who wins? 25 or 20?
25.
25. That means it is going to move where? It is going to move down with an acceleration A. Yes or no? Yes or no? Now, how do I find the acceleration? Now, remember, there is not only 25 here, but it is also 20 up. I have to find the net force. What is the net force? Can anyone tell me? Net force. Net force will be 25, which is downwards, minus 20, which is upwards. Do we understand this? 25 down, it is moving down, minus 20 up, it is not moving up. That should be equal to m into a, 5 into a, and I end up with 1 meter per second square. And in which direction? It is downwards. Do we understand this? 1 meter per second square downwards on the plane. That is the answer for this one. Do we understand this, or this has gone above that saying bye 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 bye? I'm going, don't worry about me. Okay. Now side by side, I will just put this one more question, and I think you can do it very quickly. Again, same question, same scenario, same everything. This is 5. Now I put a force of 30 Newton upwards. Now can you tell me first what is going to happen? Where is it going to move? What is going to be the acceleration? You have 2 minutes to give me the answer. Your time starts now, my dear friends.
And upwards, sir.
Yes, beta?
1 upwards, sir. Upwards.
1 meter per second square upwards. Everyone got this? Again, I will repeat the same step. Sketch is drawn. I will have to draw the free body diagram. This is 50. This is 25. Everyone knows it. I have done it so many times. This is 25 root 3. This is the normal reaction, and it is not going to go dung 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 dung. So n becomes 25 root 3. Now we see this is 30. 30 Newton is trying to pull it up. 25 Newton is trying to pull it down. Who will win? 30 Newtons definitely is going to win. So it is going to move upwards with an acceleration A. 30 is upwards. So what is the equation? 30 minus 25 is equal to 5A. Your A becomes 1 meter per second square, but now it becomes upwards. Anyone understands this? Yes or no? No, yes. Okay. Now, having understood this, Now you have this question coming away. Everybody noted on the previous one? Now
Yes,
you
sir.
have instead of one block, and I will not give you more than two, because if I just make three, doesn't make any difference. The concept remains same. Now I have two blocks, 4 kg and 6 kg attached like this. And I have a force of 40 newtons. Now remember, I could have made this question in this way, that instead of giving you 40 newtons like this, I could have given you a force like this, let us say 50 newtons, and I could have given this angle as 37. Do you understand now how to do it? You just have to take the component, yes or no? So I'm not making any fancy questions. I just gave you a straightforward one. This force is 40 newtons. Now you have to tell me what is the acceleration of this block. Are the block going to move up, or are the block going to move down? Also, you have to tell me whether the block will move with the same acceleration or different acceleration. Same or different?
Same acceleration, sir.
That is your hint. If you understand what we have done in the previous questions, you should be able to give me the answer. Your time starts now. 2 minutes. अभी अभी टेप रखा है क्या? चौड़ा वाला टेप लगा दो उसको भी, चारों तरफ से गिरेगा नहीं। चौड़ा वाला टेप है ना, काट के लगा दो चारों तरफ। वो लगा दो डबल साइडेड
4 meter per second square.
कहाँ है?
Hello, sir.
Yes, anyone got any answer?
Sir, downwards.
Yes?
Sir, acceleration is downwards.
Acceleration is downwards, that is correct. How much? Acceleration is downwards, that is correct. How much? You have time, don't worry. I want you to do it yourself, nothing else. Yes, no one? Shall I do it?
Sir, 1 meter per second square.
1 meter per second square downwards. That is correct. Well done. How did you do it? Now, obviously, the full method of doing it would be to isolate the blocks, take the 4 kg block separate, take the 6 kg block separate, draw their free body diagrams, write their equations and solve it. But now I understand that they are going to move up with the same acceleration. Whether it is they are going to either move up or they are going to move down with the same acceleration. Do we understand this? They are going to move either up or down with the same acceleration. So if they are going to move with the same acceleration, why not treat them as one body? So I treat them now as one body. I treat them now as one body. Now, what is the total mass of this body, bacha? The total mass of this body is 10 kg. So the total downward force is 100 newtons. Do we understand this? Do we understand this? I'm drawing them together. Then I will have one component of this force which will be 100 sine 30. 100 sine 30 is 50 newtons. Yes or no? That means the force which is trying to pull them downwards is 50 newtons. The force which is trying to pull them upwards is 40 newtons. The entire system. Who is going to win? The 50 Newton force is going to win. That means they are going to move down with an acceleration A. I can write the combined equation and I'll get the value of A. What is the combined equation? 50 minus 40 will be equal to total mass 10 into A. So the value of A will be 1 meter per second square. Do we understand this? Having said that, now I could have asked you, what is the tension in this string? T. If I would have asked you what is the tension in the string, can you now tell me the answer for tension in the string? Tension in the string connecting the block 4 and 6. How are you going to do this? Anyone? Any idea?
Sir, 10.
10. How did you get 10? Yes, 10 is correct. How did you get 10?
50 minus 10, sir. 50 minus 40, sir.
50 minus 10, sir. 50 minus 10 is 40, sir.
Sir, 6 plus 4. 10.
6 plus 4, 10. Whatever. Whatever comes in our head, we will give the answer. 6 plus 4 is 10, the tension is 10. That's it. Okay. How are we going to do this? To do this, what will I do? I will only take this block as one system. If I take this block as one system, this is 40. This will be 20. Yes or no? And the only force acting on this block or this system is T, which is upwards. but I also know that this system is going to go downward with an acceleration a, and I already know the value of this a. Yes or no? Now I can write the equation of this block, and I'm doing same thing which I have done in the previous cases. The only difference is here I have force not only in one direction but also force in that second direction. So what is the equation for this block? If I make it, it will be 20 minus t will be equal to 4a. Yes or no? Yes or no? Do we understand this? Yes or no? A is 1. So from there I can get the value of t. 20 minus 4, and the answer would be 16 Newton. Do we understand how I got this? Yes or no? Same thing I have done, which I had done in the previous cases. The only difference here is since the block is kept on an incline, we have got one force which is going downwards. And because of this, the equation look somewhat different. Shall we move ahead in life? Now let us move to this question. Okay. Everyone understands what we are doing? This is the next question. This is a very famous question, it has come in various ways in various exams. So what do I have? I have two blocks which are connected by a string. I hope you can see that string. And then the upper block is pulled up with a force of 120 newtons. What you have to tell me is the acceleration of the blocks. The first thing that I'm going to ask you is, are the blocks going to move with the same acceleration or are they going to move with different accelerations? Same or different? Same or different? The two blocks, are they going to move with the same acceleration or are they going to move with different acceleration? Yes. Oops. No idea?
Same, sir.
Same, sir. Second question. Are the two blocks going to move upwards or are the two blocks going to move downwards? Are the two blocks going to move upwards or are the two blocks going to move downwards? Yes. So whatever be the case, I will give you time 2 minutes to solve it. If you can do well done. If you can't, I will tell you how to do it.
A 2 meter per second square.
2 meter per second square is correct. Upwards or downwards? Upwards. That is also correct. What about the others? Everyone got the same answer? How are you supposed to do this? Once you realize that both the bodies are going to move as one system, the question becomes very simple, because now you can take these two blocks as one and write the equation. If you take these two blocks as one block, what is the total mass of the block? Total mass of the block becomes 10. So the downward force becomes 100 newtons. 100 newtons is trying to pull it down. 120 newtons is trying to pull it up. Where it is going to go? It is definitely going to move upwards. What will be the equation of this entire system? 120 is upwards. 120 minus 100 is downwards, will be equal to ma. Total mass is 10 into a. From there you will get the value of a as 2 meter per second square. Everyone got this answer? One more question can we ask. What is the tension in the string between the two? What is the tension in the string between the two blocks?
Completed.
What is the answer for tension between the two? Yes, what is the answer for tension? I asked you to solve the question, na? What were you doing? You're solving the question, no? Yes, what is the value of this tension between the two strings T? Anyone got the answer? I was waiting for your answer. Anyone with an answer?
17 newtons, sir.
17.
72.
72 newtons looks good. How are you supposed to get that answer? So for getting that answer, what you do, You just take the lower block as the block or system. You understand this? The force in the downward direction on this lower block will be 60 newtons. The tension is upwards for this lower block. What is the equation? The green equation. Remember, this lower block is also moving. Oops, wrong color. This lower block is also moving upwards with an acceleration a, my dear friends. So the equation becomes T minus 60 is equal to not the total mass, only 6a. So T becomes equal to 72 newtons. Everyone understands this, yes or no?
Yes, sir.
Now solve this question.
Four meter per second square, sir.
Sir,
Anyone got any answer?
sir, acceleration.
Sir, 4 meter per second square.
4 meter per second square, upwards or downwards?
Tension
Downwards.
What is the tension between the two strings?
42 newtons.
18 Newton, sir. 18 Newtons.
18 newtons. Okay. So how are you supposed to do this? To find out the total acceleration, they are going to move together. I will take these two blocks as one system. The net force downwards is 50 newtons. The net force upwards is 30, so it is going to move down. 50 minus 30 is equal to total mass 5a. From here, you can get the value of a as 4 meter per second square. Everyone got this? So this system is going to move downwards with an acceleration 4 meter per second square. If you want to find out this tension, you can take this as one system. The downward force on this system, the green, this one will be 30 newtons. It is moving downwards, so T30 minus T will be equal to 4 into A, 3 into A. So T becomes 18 newtons. Yes or no? Anyone got this? Okay. Now, sometimes what can happen is the rope can also have mass. The rope can also have mass. Now, if the rope has mass, you can treat that rope also as a body. Do we understand this? So now let me give you a question where the rope starts to have mass and you must understand how to solve it. So here comes the question. A block of 6 kg mass is attached to a rope of 2 kg. Now this entire thing is moving downwards with an acceleration 5 meter per second square. Do we understand this? You have to find out the force or tension at the highest point of the string and tension at the lowest point of the string. Now remember, as soon as your string starts to have mass, the tension at different points of the string would be different. Do we understand this? If the string starts to get mass or the string has mass, the tension at different points of the string would be different. Here is the question where string has mass. Now it is over to you to tell me the answer. Two things have been asked. Tension at point A, tension at point B, the lowest point. That is the only two things.
So TB is equals to 13 newtons.
TB is equal to 30 newtons. What about TA?
So 2A is equals to 2 newtons.
Is it possible? Tension at the highest point less than tension at the lowest point? No, I don't think it is possible. 2 newtons. How did you get 2 newtons? No, no way. Try it again. I guess you are doing the right thing. Probably made a mistake somewhere. I'll give you 2 more minutes to do it.
40 newtons, sir.
40. Now the answer has changed. 40 newtons looks okay. I hope we are not playing Kaun Banega Crorepati here. That we are guessing. So how are we supposed to do this? Now let us first find the tension at point B. Now if I have to find tension at point B, I will draw the free body diagram of this and I just simply take this block as one system. Do we understand this? The downward force on this block, only one block, is 60 newtons. The upward force is TB, and this is moving down with an acceleration of 5 meter per second square. Force is downwards, tension is upward, it is moving downwards. So equation becomes 60 minus TB will be equal to M into A, 6 into 5. So tension at point B becomes 60 minus 30, 30 newtons. Everyone understands this? Yes or no? Then to find out the tension at the highest point, remember tension can only pull. So remember tension will be upwards like this. Do we understand this? Then I take this entire block as one system. What is the downward force on this system? The total mass of this system becomes 6 plus 2, 8. So the net downward force on this system would be 80 newtons. Yes or no? So if I make the equation of this system, 80 is downwards, TA is downwards, and the acceleration is downwards. So the equation becomes 80 minus T is equal to 80 minus TA, sorry, is equal to 5 multiplied by 8. Tension at point A will be equal to 40 newtons. Do we understand this? Yes or no? Now, if I could make a third question here, what is the tension at the middle point? C is the middle point. C is the middle point of the string. What will be the tension at the middle point of the string? Yes. What will be the tension at the middle point of the rope? Yes. What is the tension at the middle point of the rope?
35, sir.
35. There are different ways in which you can do this. You can do it by common sense. At the lowest point it is 30. At the highest point it is 40. So in between it will be 35. That's true. You can do it this way. Or you can do it in this way. You can draw half of the string and the block as one system. This is 6 kg. This is 6 kg. If half of the string is there, then the weight will be mass will be 1 kg. Yes or no? You can take this body as one system. So the tension at point C, let me call this point as C. Tension at point C is TC. What will be the total weight of this system? It would be 70 newtons. Yes or no, my dear friends? And this system is again moving down with an acceleration of 5 meter per second square. You can write the equation of this system on your own, but I will write it for you now. 70 minus tension at point C will be equal to total mass 6 into 1. 6 plus 1 is 7. 7 multiplied by 5. Tension at point C will be 35 newtons. Do we understand this? Yes or no? No or yes? Anyone understands this? Mass of the rope does not make any difference to the eventual question. Everything is similar. Now I'll give you this question. And I hope that you can do it on your own. Just putting the question here for you. put it in different parts, and I'll also put the diagram so that you can give me the answer fast. So this is the question, bacha. A 5 kg block has a rope of mass 2 kg attached to its underside and a 3 kg block suspended from the other end of the rope. The whole system is accelerated upwards by 2 meter per second square by an external force F naught. You can see the diagram. What is F naught? What is the net force on the rope? Net force on the rope. Remember the question. What is the tension at the middle point of the rope? Let's see who gives me the answer for this one. Yes, bacha. Anyone with an answer? Shall I do it for you, bacha? Okay, I'll give you time.
F naught is 60.
Yes, bacha.
Not is 60.
F naught is
60.
no. F naught is not 60, beta. Try again. Must have missed something. Try it again. I know you can do this. Trust me.
Newtons.
120 newtons is the right answer. 120 Newton is correct. 120 newtons is correct. What is the net force on the rope? And what is the tension at the middle point of the rope? That two answers remain. Try everything. Give me the answer when you have everything. 120 is correct. No questions asked, no answers given. 120 is correct. What about the other answers? I'm waiting patiently for your answers. Don't worry, I'll give you time. I want you to do it on your own. Yes, bacha.
Mid point is 60, sir.
Which one? Part B or part
Midpoint,
C?
sir.
Midpoint is 60.
60.
No, midpoint is not 60, it is 48.
40 newtons.
The answer that I have is 48. I don't know whether this is right or wrong. The answer that I have is 48. It may be wrong. There may be a printing mistake. Tell me what are your answers, my dear friend.
Forty newtons.
40 newtons. Okay. What about the others? I'll give you one more minute. What about the part 2? Anyone got the answer for this? Part 2. Net force on the rope. I want all the 3 answers, bacha. I'll give you one more minute. Don't worry. One more minute. I know you can do this. It's a simple question, bacha. It's a simple question, trust me. Should I do it? Have you all given up? Lost? Given up, lost? Shall I do it?
Yes, sir.
F naught. Everyone got the value of F naught? We got the value of F naught or not? Yes, you got the value of F naught. How did you get the value of F naught? Tell me that. How did you get the value of F naught? Huh? No one knows this.
F naught minus.
F naught
and
minus.
equals to 2 into 10.
Yes, that is correct. That is what you need to do. And you have done it correctly. I must appreciate that. So, to get the value of F naught, what do you do, bacha? Is you take this entire block as one block. The downward force on this block, everyone can see this, yes or no? Is 100 newtons. This entire system, oh, sorry, not upwards, not downward. This entire system is going upwards with 2 meter per second square. I write the equation for this block. F naught minus 100 is equal to 10 into 2. F naught becomes 120 newtons. Yes or no? No or yes? No one tried question number B, so I'll do B later on. No one tried B. Anyone tried to do B? No one, no? Okay, let me first do C, because this is what we have done. Let me first do C. To get C, tension at the middle point of the rope, I will take it till this point. This is the middle point of the rope, and I will take this as one system. Now, what is the force on this system? There is a tension in the upward direction. Yes or no? We do understand this. Tension at point C, TC. And then there is a force in the downward direction. How much is the downward direction force? Tell me fast. The block is 3 kg and the rope remaining part, half part is 1 kg, 4 kg, 40 newtons is downward. Yes or no? No, yes. Huh? Just make the equation. TC is upwards. TC minus 40 is downwards, beta. That must be equal to m into a. Total mass is 4. Acceleration is 2. So tension at point C is 48 newtons. What was different in this question that we have not done? Anyone got the answer for 48 newtons? Yes, I can see some hands being raised. Now the only part which no one tried was the net force on the rope. How do you get the net force on the rope? So let us make this rope. Now there are different ways to do this. There are different ways to do this, but I'll tell you the simplest, easiest, fastest way. Net force on the rope. Now there is no force on the rope in the horizontal direction. Do you understand this? There is only force on the rope in the vertical direction. F net. And this F net, whatever this net force is, must be equal to mass into acceleration of the rope. Because there is no net force in the horizontal direction. There is only force in the vertical direction. That net force should be equal to m into a. Mass of this rope is 2. Acceleration is 4. So the answer is net force on the rope is simply 8 newtons. Do we understand this, or this has gone above and saying bye bye, bye bye, I'm going, sir? I had enough of this. Bye bye. It was so simple. You must understand that every question that you are going to see in an examination hall, or every question that we are going to do in the class, is going to be simple. What you have to understand is whether you can do it in the simplest possible way. Do we understand this, everyone, how I've done this? Or do I need to explain it again? Tell me fast. We understand this?
Sir, acceleration.
Yes, bacha?
Acceleration.
I can't hear you, bacha.
Acceleration, sir.
Yeah, okay. 2 into 2, sorry. I made a mistake. Not a problem. Thanks for pointing it out. So it is not 2 into 4, 8, but it is 2 into 2, 4 newtons. That is correct. Do we understand this? Yes or no? No, yes. This is gone above and saying bye bye, bye bye, sir. I'm going. I had enough of questions today. Bye bye, I'm going now. Shall we move on to the next one? Everyone is ready. Remember, very few question comes from Newton laws. I'm only concentrating on the ones which I think that can come and which can be done in the examination hall. Okay. Chalo. This is a question which has come in one of the previous JEEs, and you understand the concept. So you can do this. Now, a horizontal force F is applied on a rod. This could be a rod, this could be a rope. Basically, this question is, if you apply some force on a body which has length, what is the value of the force, or what is the force in that rod? If this was a rope, it would have been tension in the rope, but the question will not look good. Rope being pushed will not be looking so fancy. Therefore, they have made it a rod. So a horizontal force is applied on a uniform rod of length L kept on a frictionless surface. Find the tension in the rod at a distance x from where the force is applied. So apply a force on the rod or the rope. So this is a rope with a mass or rod with a mass. Same concept, same thing. What is the force in the rope? What is the force in the rod at a distance x from where the force is applied? You have 2 minutes to do this. Get the answer and stay happy always. 2 minutes. I can see some happy faces, but I will be more happier if those happy faces turn into more happy faces with the answer being solved, with the question being solved and answer being achieved. That happiness is more glorious than anything, any happiness that you can have. Solving a question with your own hands, small hands you have, I know. So that happiness is, what should I say? Great. Again, the only way you are going to get anywhere near an IIT by clearing it is when you solve question with your own hands. If I solve them and you write it down from the board, I'm sure that clearing an IIT or a JEE would be pretty tough. The only way you're going to do it is by doing it with your own hands. Then only you understand what mistake you make. And then you can rectify those mistakes. Unless and until you understand your mistakes, you will not be able to rectify them. I'll tell you my case. In my case, in the year 1996, when I appeared for the JEE in the first time, I never practiced the calculation. I said, calculation I'll do in the examination hall. Hey, what is calculation? 2 into 2 with that. I am Master Gudenia. I am the biggest, I'm the greatest mind in the entire universe. I will do calculation. No way. Heck, calculation that. And when the examination paper came, it was a surprise because the entire paper was calculation based and I was dumb. I knew how to solve question, but I did not know how to calculate. So my rank was 3,800. The next year I prepared for calculations, but then the paper pattern changed. But I significantly improved my rank to 1,800. And I thought and I knew that that is the best that I could do. Chemistry killed me actually. In the first year, I did not study inorganic. I said, inorganic. What inorganic? In the second year, I only studied inorganic. And the paper came from physical. And I was like, whoop, dumb, dope. That's why I hate chemistry. And I love physics. Coming on to this question. Enough philosophy. Now question. And I can see crowd getting less and less. Where are everyone? Where is everyone going? Lunchtime? No, lunchtime is already over now. People disappearing. People are disappearing faster than the leaders disappear after elections. Before elections, everyone is there right in front of your house. Open the door and you'll find a leader asking for votes. As soon as the elections are over, they disappear. Students are also like this now. They are disappearing faster than the leaders disappear. Leaders at least wait till the elections are over. They are not waited till the class is over. They have disappeared between the class. Voting is already done. The what? The result is already in the ballot box. What do I need to do? Forget about voters. Faster! I'm waiting for the answer. No answer? Shall I do it? Rather than waiting? So how are you supposed to do this? Anyone, any idea? No idea, get idea. Okay. So how are you supposed to do this? Now remember, we don't have to make the equation in the vertical direction. So let us not be concerned about the vertical direction. I will take this entire rod as one body and I will make the equation of this entire rod. This entire rod is going to move ahead with an acceleration a. Yes or no? We understand this? This entire rod is going to move ahead with an acceleration A. Do you understand this? Yes or no? Okay. If I call the mass of this rod as m, remember mass is not given, but let me call this mass as m. I can write the acceleration of this rod. I can write the acceleration of this rod as F by the total mass m. Do you understand this? Yes or no? Huh?
Yes, sir.
Now, I have to get the tension in the rod at a distance x. And there are two ways to do this. I will use the shortest way. I will take this portion of the rod as one body now. This portion of the rod. Now, what is causing this portion of the rod to move forward? There is a force or tension in the rod coming like this. Yes or no? So I call that tension as T. This is the tension at a distance x. Now this tension, this force is going to pull the rod, and this rod is going, and this part of the rod is going to move forward. Now what is the equation for this green part of the rod? I hope you understand the green part of the rod. Yes or no? The green part of the rod is this rod. Ding, 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 ding. The green part of the rod is this rod. So what is the equation for this green part of the rod? The green equation. What is the green equation? The forward force is T. That T should be the mass of this portion multiplied by A. Yes or no?
Sir.
Now, how do I find the mass of this portion, beta? How do I find the mass of this portion? This is not physics, this is maths. The mass of the entire rod is m. Yes or no? Mass of the total rod is m. So mass of a unit length will be m divided by L. Yes or no? I have to find the mass of L minus x. This distance is L minus x. So what will be the mass of L minus x portion? It will be m by L divided multiplied by L minus x. Do we understand this? That's it. You put everything together and you will get the tension in the rod. The tension in the rod will be m by L into L minus x multiplied by A. A is F by m. Your m and m gets cancelled and your tension becomes F into L minus x divided by L. Do we understand this? Yes
Yes, sir.
or no? I'll give you 1 minute to note it down. Once you have noted it down, let me know. Done, everyone?
Done, sir.
Now, this was the method from physics. I could have done this question with something even not related to physics. I could have done this question with something even not related to physics. How could I have done this without using physics at all? How could I have done it without using physics at all? No physics, no acceleration, no mass, nothing. How do I do this? So now look at that method without using any physics. You understand that method of physics now? Now, simple common sense. If you want to call it maths, you can call it maths. This is x is equal to 0. The force is F over here. Yes or no? This is x is equal to L. At this point, the force would be 0. Yes or no? So force varies from x is equal to 0 to x is equal to L. The force varies, and the force varies linearly. The force will vary linearly because this is a uniform rod. This is the equation of a straight line actually. When x is 0, the value of force is F. When x is L, the value of force is 0. It's an equation of line with a negative slope. Do we understand what I'm talking? It varies steadily. So now you can write the equation without looking this. If I start from this end, I can easily write the equation of force. If I start from this end, if I count x from this end, I can write force at any distance x will be equal to total force F divided by L multiplied by x. Yes or no? I don't have to do anything. I can write it here. From this end, I can write it like this. So from the other end, what will I write? From the other end, I will write force as a function of x would be equal to F into 1 minus x by L. That's it. Okay. No physics, simple maths. Do we understand how we done this? You put the value of x as 0, you will get F. You put the value of x as L, you will get 0. Force varies from graph. This is F and this is x. The graph is like this. Do we understand this? When x is 0, this is F naught or F. When F is 0, x is equal to L. This is the equation of this line, nothing else. Do we understand this, or this is gone about saying bye bye, sir? None. Too much. We get this, yes or no? Without using any physics, do we understand this? Now, if you understand this, can you give me the answer for this one? Anyone has understood this? How I have written this? Can you give the answer for this one? Two forces, F1 and F2. F2 is greater than F1. Are applied at the free end of a uniform rod kept on a horizontal frictionless surface. Find the tension in the rod at a distance of x from the end A.
Sir, show the previous slide.
What is there in the previous slide? See? I've done it from the math point of view, not from the physics point of view. When you're done, please let me know.
Completed, sir.
Move on to the next question, bacha. If you understood the previous one, you can look at this one and tell me the answer. At one end, the force is F2 in this direction. At the other end, the force is F1 in this direction. You have to find a force as a function of x. Yes, anyone with an answer? At one end, the force is F2. At the other end, force is F1. We have to find the force from the end of F2. And the answer is so the answer is, remember the answer? The answer is F2 minus F1 multiplied by x and divided by L. Now, as soon as you put this F1 as 0, if you put this F1 as 0, you will get your previous answer. You remember your previous answer? This one. Both of them are in the same form. You can write this Fx as F minus F into x by L. Here, in place of this F, F2 is given. And in place of this F, F2 minus F1. Because on the other side, there is no force here. So remember this form. If you just remember this one, you should be able to find out the other one. Do we understand this? Just note this down. I'll give you 2 minutes to note it down, then we'll move ahead in life.
One second.
Yes, bacha?
Can I explain once again?
Just remember it, beta. Just remember it. Just remember it as a concept. Okay? Just remember it as a concept. Keep that diagram in mind. F2 minus F1 into x by L. F2 minus, just remember it. Let's not waste time into things which may not be so important. Okay? Got this? Just remember. You can remember it, no? Keeping the diagram in your head. Just remember it. Nothing else. Okay? Shall we move ahead? to things which are more important? Okay, let's move ahead and solve questions of this. This gentleman is known as the Atwood's machine. What is this known as? Atwood's machine. Does not look like a machine, but it is known as the Atwood's machine. In the simplest form, this is known as the Atwood's machine. Now, this Atwood's machine basically consists of two masses. Obviously, they are not of the same value, M1 and M2, and they move over a pulley which is ideal. That means it is frictionless. Now, what we are supposed to find out, if we lose, if we hold these masses like this, nothing will happen. If you leave this masses, then what will happen? One will go down, another will go up. Yes or no? If I assume that this M2 is greater than M1, that is the condition we normally take. M2 is greater than M1. What will happen to this system? Tell me first. M2 is greater than M1. What will happen? M2 is greater than M1. What will happen? Someone will come down and someone will go up. What will come down? M2 or M1? What will go down? What will go down? M2 or M1? 2. So M2 goes down. Everyone understand this? No physics. This is common sense. And M1 comes up. If I say that M1 comes up with acceleration A, what will be the acceleration of M2 downwards? Will it be same or will it be different? If M1 comes up, same, sir, na? Because they are attached to the same spring, the same string. The only thing here it is, the only way it is different is, up till now what was happening was both the blocks or all the blocks were moving in the same direction also, right?
Yes.
They were moving with the same acceleration in the same direction. Now what is happening is they are moving with the same acceleration magnitude wise, but their directions are different. Do we understand this? So direction has changed. And who has changed this direction? Your pulley has changed this direction. And therefore we say that this pulley is a way to change the direction of motion. Do we understand this? There are two quantities that they might ask you to find out, and I will give you the chance to do it for me. The two things that they ask to find out is find out the tension in the rope or the string. How many rope or string do you see? One or two? Right now it is one. Find out the tension in the rope and the acceleration of the blocks. I'll give you 2 minutes to do it. You don't have to do anything different. Just have to do simple things. I'll give you 2 minutes. Yes, anyone got the answer? Eh?
M1 plus M1 G.
G M1 minus M2 by M1 plus M2.
Beta, you must understand that M2 was greater than M1. Did you remember that? M2 was greater than M1. Can you now tell me the answer again? M2 was greater than M1, not the other way around. What is the answer now? M2 was greater than M1. M2 was greater than M1, beta. Can you tell me the answer now? Confused? Don't be. It's a simple question, bacha.
Sir, M2 G minus A is equal to T.
Okay, I think everyone is giving me the answer, but I'm not able to hear you clearly. Okay, everyone got the answer. Answer is M2 minus M1 into G divided by M1 plus M2. Everyone got it? Well done, well done. That is good. If everyone got this, that means I don't have to do. And when I don't have to do a problem, I feel happy because that means that we are doing things correctly and you are able to do the problem on your own, which is the only thing that I want. How? Okay, how are we going to do this? How do we do this? So we go by the same method. There is no different method that I've got. Let me rub this one out. So the method is very simple. I will just write M2 here, M2G here. I will draw the free body diagram. This is T, this is T, this is T, this is T, and this is M1G. Right? Now I paint this block as pink, and this is the pink equation. This block is moving down with the acceleration G. So I will write the pink equation. M2G, it is going downwards. M2G minus T will be equal to M2 into A. That becomes, let me call this equation number 2 because this is block number 2. Let me paint the new block, the other block as green one. And this is the green equation. Remember, it is moving up with an acceleration. So I have to do upwards minus downwards force. T minus M1G is equal to M1A. Let me call this equation as equation number 1. I can add equation number 1 with equation number 2 and I will get my result. What is the result? I can get the acceleration as M2 minus M1 into G divided by M1 plus M2. Once I get the value of A, my bacha, you just put the value of A here or you put the value of A here. Anywhere you put the value, you will get the value of tension. Can anyone tell me what is the value of tension that you are getting, bacha? What is the value of tension that you are getting? Anyone got the value of T, tension? You can put it in equation number 1 or put it in equation number 2. You will get the value of the tension in the string. Can you tell me what is the value of tension in the string? No one got this? Tension?
2G into 1 M1 minus M2 by M1 plus M2.
Some mistake in calculations? The value of T that you are going to get beta will be 2 times.
Into M1, M2 by M1 plus M2 into G.
Yes, that is correct. 2 times M1, M2 upon M1 plus M2 into G. That is the correct answer for tension. That is the value of tension in the string. Now, we cannot get a shortcut, get a shortcut for tension, because it's very difficult to get tension from some short thing. But if you understand the question properly, you can get the value of acceleration quite fast. How can you get the value of acceleration quite fast? And we will discuss this in details in the next class. Can you think of something that could give you acceleration faster without writing so many equations? Now remember, how did we get the acceleration in the case? We took everything as one mass and we got the value there. Now here, now think how I'm going to do this. If you draw the free body diagram of this, the force which is trying to pull it down is M2G. The force which is trying to pull this block down is M1G. So basically, if I talk about this entire system, there is one force M2G which is trying to pull it downward on the right hand side. There is one force M1G which is trying to pull it on the left hand side downward. Do we understand this? One force is trying to pull it down like this. The other force is trying to pull it down like this. Now, where will it go? Depends on which force is stronger. Here, this M2G is stronger. Yes or no? So this M2G is stronger than this one. But this is also trying to pull it down. This is also trying to pull it down. So what is the net pulling force which is downwards? What is the net pulling force which is downwards? Both are looking downwards, but they are acting in the opposite sense. So if I say the net pulling force divided by the total mass, I can get the value of acceleration. Now also, the net pulling force in this case is the bigger force minus the smaller force. The bigger force is M2G, the smaller force is M1G. If I subtract the two forces, now this question will start to look like the question where there was one force in the upward direction and one force in the downward direction. If upward is more, it is upward minus downward. If downward was more, it was downward minus upward. Here also it is the same case. This force is trying to pull it downwards, yes or no? And this pink force is actually trying to move it upwards. So it is again downwards minus upwards in that sense. Do we understand this, or this has gone above our head saying bye bye? Sir, done. We are done. So we will try to solve more questions from this concept. Remember, even if you don't understand this, this is the short way of getting the thing. If you don't understand this, you know how to make the equations. That is also there. That is always there. You can use that. If not, if you want to get the answers quicker, you can use this one. So we'll try to solve more questions on this and try to wind up this motion of connected mass by next class, so that we can move on to other topics. Take care. God bless all of you. Bye bye. See ya.